Alrighty, moving on to polynomial functions of higher degrees. So not just x squared, but x to the third and the fourth and, well, whatever. So the first thing we got to remember about polynomial functions is that they are continuous. What that means is it passes this pencil test. Now let me draw x to the third here to demonstrate that. X to the third looks a little something like this. You can draw this without having to lift up your pencil. X to the fourth, it's got kind of a quadratic-ish shape, the parent function does. It's going to look a little something like this. Oop, I missed. It should go through there. Now, if you go for crazier quartic functions, it can look something more like a W shape, or it could open down, or what have you. Then there's good old f of x equals x, which is just a good old linear function. Now, let's talk about these a little bit more. Cubic, so that's an example of a cubic, but again, you can get crazier with cubics. Cubics can wave a little bit. Oh, that's looks like the stock market. Could look like that, could get a little crazier. What I want to focus on, this has an odd degree. X to the fourth has an even degree. And then x to the first has, again, an odd degree. So taking a look especially at the, oops, sorry, I'm not on the graph, or I'm not on the page there. So looking at the two odd degrees, you'll notice something about them, that one arrow is pointing up while the other arrow is pointing down. And it could go in the other direction too. Like you could have a linear graph that looks something like that, where it's up and to the left and down and to the right. Oops, sorry. So let's refresh ourselves in this end behavior thing. So end behavior, or what the graph does to the right and the left side, can be determined by two things. First thing is what we just identified with the odd and even degrees. So it's odd or even, so odd numbers being 1, 3, 5, 7, 9, etc. Even numbers being 2, 4, 6, 8, 10, etc. And its leading coefficient. So what value comes in front of the highest degree term? So we're going to make a quick table. This, if you remember back to Algebra 2, if you went to Alabama for Algebra 2, you've seen this table before. So the test, if you have an odd degree with a positive leading coefficient, let's just do a rough sketch of what that could look like. An odd degree with a positive leading coefficient might look like this. End behavior, this is a format hopefully you remember. It's going to be two sentences. One's going to say, as x approaches negative infinity. In other words, as you go super far to the left, where's the graph going? We're going to say f of x, or whatever the function's name is, approaches, in this case, it also approaches negative infinity. So on the left side, that's your left side, on your left side, it's pointing down. Then on the other side, as x approaches positive infinity, f of x also approaches positive infinity. So as it goes to the right, it's going up and to the right. Let's just keep going with the odd degrees. An odd degree with a negative leading coefficient looks maybe something like this. Now that could be, it's something higher than cubic, but it's a little crazier. So an odd degree with a negative leading coefficient, we would still say as x approaches negative infinity, so on the left side of the graph, this function, we'll still call it f of x, approaches, well the left side of the graph is pointing up, so we're going to say it approaches positive infinity. And then the other side, as x approaches positive infinity, so as we go really far to the right, this function on the right side is pointing down, so it's heading down to negative infinity. Even degrees with a positive leading coefficient. An even degree with a positive leading coefficient might look something like this. Here's a quadratic that opens up. So, following the similar pattern, as x approaches negative infinity, so on the left side, the graph is pointing up. So we'll say f of x approaches positive infinity. On the other side, as x approaches the right side, as x gets further and further to the right, the graph also approaches and points up to positive infinity. Last one, and then I'm going to summarize some stuff here, some patterns you might notice. Here is an even degree with a negative leading coefficient. Maybe it looks like this. So we're going to say, let me shift my picture so that I'm not covering that part of the screen. There we go. So for our end behavior for that one, we'll say as x approaches negative infinity, so on the left side of the graph, f of x is approaching negative infinity. It's heading on down. As we go further and further to the left side, it's going to go further and further down. And then on the right side, we're going to say as x approaches positive infinity, well, the right side's also going further and further down. So we're going to say f of x approaches positive infinity. Couple things to note here. Even degrees go together, so they're either both pointing up, both going to positive infinity, or they're both pointing down. Odd degrees, they go in opposite directions. So an odd degree with a positive leading coefficient goes up and to the right, down and to the left, where an odd degree with a negative leading coefficient goes up and to the left, and then down and to the right. Also notice for positive leading coefficients, the right side is always pointing up, whether it's an odd degree or an even degree. If it's a positive leading coefficient, it's pointing up and to the right. For negative leading coefficient, it's always pointing down and to the right, regardless of what your degree is, odd or even. Now let's take this and apply it to a couple of problems. So we're asked to describe the end behavior of the graph of each function. So what I'm going to have us do is probably a little bit of overkill, but I'm going to have us identify the degree and leading coefficient for these. So the degree, or the leading coefficient for f of x equals negative x to the third plus 4x squared plus 25x minus 100. The leading coefficient is negative 1. The degree is 3. So it is a negative leading coefficient, and it's an odd degree. So since it's a negative leading coefficient and odd degree, we're going to say as x approaches negative infinity on the left side of the graph, let's see, this one's called f of x. F of x approaches positive infinity. It's pointing up and to the left. As x approaches positive infinity, so on the right side of the graph, an odd degree with a negative leading coefficient is going to be pointing down and to the right. So it's going to be heading to negative infinity. I'd like you to pause the video, try the other two on your own. You don't have to write leading coefficient and degree every time, but it doesn't hurt. Okay, you've paused it. So let's see. Positive leading coefficient, even degree. So this one's going to be as x approaches negative infinity, well, that side of the graph points up. So we're going to say f of x approaches positive infinity. As x approaches positive infinity, the right side of the graph, f of x is still approaching positive infinity. It's going up on both sides. Last one, it's a positive leading coefficient with an odd degree. So, following that same pattern from the previous page, as x approaches negative infinity, f of x also approaches negative infinity. In other words, the left side of the graph is pointing down. And then on the right side of the graph, as x approaches positive infinity, f of x is pointing up. So it's pointing up to positive infinity. And that's all for end behavior.